Find the shortest distance between a parabola and its inverse function. So we have the parabola function of x plus a squared plus 9/4. And its inverse function we can find is x minus 9/4 squared minus 3. And this is valid with in the range of x greater than 3. It turns out any function and its inverse function is always mirrored by the x over y equal x diagonal line. What that means, since this x and the inverse function are mirrored across the y over x, that means their shortest distance, which is a vertical line, must be perpendicular to the y equal x. And that means it should have a slope of -1. Basically, that shortest distance must have a slope of -1. So, okay, so that's the trick to solve this problem. Now we can find this line, let's call it line AB, with the point B, A, AB. So that line will be has a slope of -1, and we're going to assume there's a point on fx. That point is, let's call it alpha beta, and that's also point B, alpha beta. On the inverse function curve, there's the point A. We call that with the coordinate A and B, small a, small b. So that's the linear function of the green line, AB, with a slope of -1. And the next step, we need to find alpha beta. We need, so we can use the formula of the fx, and then we just put alpha beta there. We have beta equal alpha plus a squared plus 4/9. Now, because the AB is perpendicular to the tangent of this curve, the tangent MN can be found by the derivative of this fx. The derivative of fx is 2x plus 3. What that means is that since AB perpendicular to MN, and AB has the slope of a -1, and MN must have the slope of 1. That means 2 alpha plus 3 should be equal 1. And by this, and we can solve alpha, which is at the value of -2.5. And then we plug in the formula of fx and solve beta, which is 2.5. Okay, next we need to find AB. And we can use the mirror trick again, because AB and alpha are mirror across y over y equal x. So AB and alpha are just mirror each other. That means A equal beta and B equal alpha. And then we have its value. And that's using the mirror trick. If we don't use that, we can also solve it using the similar method as we did for alpha beta. So because the big A, big B perpendicular to JK, so we know the slope of JK must be what? 1. The slope of JB is the derivative of the inverse function gx at this form. So by solving this function, we can get A equals 2.5, and plug in the inverse function gx, we can get a B, which is minus 2.5. With the A and B solved, then we can calculate the distance, which is the length of A and B. A and B here. And this is a formula for the Euclidean distance. And we can just solve that from this, the value. Okay, this is a very interesting question.